Hello students, so far we have done a lot of work on classes and objects, and as you know, object-oriented programming is a feature which allows us to represent objects in the real world. Either they are living objects like human beings or animals, or they could be non-living objects like pretty much anything that you can see. For example, we can have a student object, we can have a chair object. As you can see, one of them is living, one of them is non-living. And then what we can have is each object contains data, which describes the attributes, and it also contains functions which describe the behavior. This is the stuff that we have been practicing so far. Now, what we'd like to do is we'd like to build upon this concept and introduce a concept called inheritance, which is very core object-oriented programming. We will go over what is the usefulness of having this feature and also how to use this feature as we progress through a couple of modules. Now, firstly, inheritance, it describes relationships between objects, and it describes a hierarchical relationship between objects. What do I mean by that? What I mean by that is, for example, let's say we have in the real world, we have a student, then we know that a general student at college could actually be, in fact, a major, a computer science major, or could be a arts major, or maybe could be a medicine major. So as you can see, a student is a very general categorization, and you could have further specialization, which is either of these categories or as many categories. Now, what we say here is that a computer science student is a student, an art student is a student, a medical student is a student. So you see there is a hierarchical relationship in which CS is a subset of this big student group, arts is a subset of the student group, and medical students are a subset of the student group, and these are mutually exclusive. Sometimes they are mutually exclusive. Now, what we can also have is an art student could consist of a fine arts, or could contain, or could be a political science major. So as you can see, these inheritance relationships are pretty much like, for example, if you remember your biology chart, which is a kind of a classification of the animal kingdom and a classification of the plant kingdom, where you have the most general object at the top, which could be a human being, for example. So you could say, I could start off here, and a human being can be, this is the top level categorization, and then you have student and so on. Just like you have animal, and then a very, you could have animal here, and then you could have a carnivorous animal, and then here you could have a herbivorous animal. I'm not able to write there for some reason, but let's say a carnivorous animal could be, for example, a mammal, or it could be something else. And then a mammal consists of either, it could be a wolf, or it could be a lion, or it could be. So as you can see, this is a hierarchical structure in which the most generic entities at the top, and as we go down this chain, we can get more and more specific right up to the point that we reach this very specific category under which we are not able to split any further. So this could be a specific type of wolf, right? Specific breed of wolf. So exactly in the same way, and then what we say is that a wolf is a mammal, is a carnivore, is an animal. So there we are establishing an is a relationship, which is actually going in the reverse direction in this way. And what we are going to say is that this inheritance relationship is a unidirectional relationship. What we cannot say is that an animal is a carnivore, or a carnivore is a mammal, or a mammal is a wolf, because a mammal can be a lion or a wolf or a tiger or any other animal. So this is a unidirectional relationship in which the lower elements, they inherit the properties of the entity that's at one level above in this tree. So if we think about regular classifications in real life, then it is exactly a kind of a software representation of the relationship that occurs in a normal inheritance structure. So a computer science student is a student, but not every student is a computer science student. So we have the exact same is a relationship and the arrow working in the opposite direction. So what is the advantage, though, of having, so here is where we've got, to take another example, we've got a rectangle is a shape. As you can see here, rectangle is a shape. A car has a wheel. And you can have a triangle is a shape, a circle is a shape, an ellipse is a shape, but every shape is not a triangle. So there is an is a relationship. The difference between an is a relationship and a has a relationship is that, for example, there is another kind of relationship which is not an inheritance relationship, it's a composition relationship. It's a composition relationship. And what a composition relationship does is it actually reflects what the object is made out of. For example, a car has a wheel. There is no is a relationship. A wheel is not a car, or a car is not a wheel, but a car has a steering wheel. A car has an engine. A car has a gas tank, and a car has seats, and so on and so forth. So the two ideas in when we do object-oriented programming are composition and inheritance, and we will focus, here on inheritance primarily, but is it important at this stage for us to know that inheritance is not a composition or a has a relationship. Now, what are the advantages of, just going to see. What are the advantages of having a inheritance relationship? One of the big advantages of having an inheritance relationship is that it allows us to reuse code. And that's a huge deal when we do programming, because often programs are thousands and thousands of lines of code. And what we have here is, for example, if we give a software representation of student, then this could have thousands and thousands of lines of code. Now, if we would like to define an object which is a computer science student, then we would not like to recreate the wheel, as it were, and redefine all of those common elements between a student and a computer science student, i.e. the name of the college is the same, the address of the student is the same, the social security information is the same. Some of the general ed courses could be the same as what every single student is required to take. So there could be a lot of common information, just exactly like a parent-child relationship, in which some of the genetic information of the parent is passed on to the to the child, and the child does not have to recreate the wheel or reinvent all the genetic information. But what the child can do is add their own personal characteristics, which could be added because of environment or because of other reasons. So, in effect, what the child is doing is just providing a little unique spin-off from the parent. Could do more things than the parent, could do the same thing slightly differently from the parent, but by and large, a lot of genetic information is inherited. Exactly in the same way, what we have is, trying to see. So basically what we're trying to say here is that a lot of the code that we have already written for student does not need to be duplicated in the code that we are now writing for a computer science student, but we can indicate to C++ that a computer science student is actually a derived class or a child class of the parent student class, which tells C++ that it can automatically inherit the code or use the code. So this makes the code, number one, it makes the code reusable. So we are creating reusable code. And this is very important, especially for large programs, when we don't want to have our programs get super bulky just because we're having to duplicate all the information from the parent class to the child class. The second thing is that it helps with maintenance because if we were to rewrite code and rewrite the exact same code, any errors that crept into our child class would then have to be manually corrected by us, and any small change that we made to the parent class, for example, would now have to be reflected in exactly the same way in all of the child classes. And remember, we can have more than one child class. So that is a big task to keep all the code up to date. And so inheritance also allows us to make changes in one place and have them automatically reflected in the child classes. So this is a huge, big feature, and it's a very useful feature. What I'd like to do here is in this video is just for us now to just look at one simple example of how to do inheritance in C++, and then we will have a subsequent video in which I will dive into a little more detail of how this inheritance is to be done. So here is an example of a animal class, and this is going to be our base class. The base class or the parent class is now, as you know from your software engineering work, that we are going to use header files and C++ files. So the animal class contains a header file. You could either use this if not defined and define, or you could straight away create the class in this class template in this manner. Both ways work, and I've just commented this out because I think in some of my notes you might see this. So what I'm doing here is I'm creating a class called animal in which this age is the only attribute. This is the attribute. Now, typically what we would like to do is we would like to keep the internal information of the class as private, and therefore I can use the specifier private to indicate that age of this animal object is not everything, is not something that the whole world can see and change, right? But I'm creating public methods here. There's just two methods. This first one is the constructor, and you know about constructor because you've done this in object-oriented programming. And this is a regular method, and both these methods are public. This method is for the animal to make a sound. Now, as you can see, these are just the function prototypes, and the actual function definition is going to come in the implementation file, and which is called the animal.cpp. Here, I make sure to include my header file animal.h so that the function headers and the name of the class, etc., is going to get imported into this. Regardless, as you can see, I'm now doing something new here, which you might not have seen before. Use this two colons, which are called the scope resolution operator. What I'm saying here is that I'm now going to implement or define the constructor called animal, which is from the class animal. So please do not be confused when you see animal and animal. It just means this is the class animal, and this is the name of the constructor, which also has to be the same as the name of the class. And what I'm doing here is assigning age equal to A in this constructor. The second thing that I'm doing here is the sound method of the animal class is being defined here, and all it does is it says this is an animal sound. So this is the parent class. Now I have only one child class here, and you're free to create an experiment with adding more classes. There is a line class. So a line is an animal. We can do this. Line.h, you see here I've chosen to define it just to show you that both these mechanisms work. Here is a class called line, and I indicate that line is a child class of the animal class by indicating here with the colon here. So I indicate that this line class inherits from the animal class. Now I have created an attribute called carnivore. Now this is not something that every animal has, but a line definitely is a carnivore. And I've also got I'm going to make this private at some point. And this is a public constructor to construct the line. And the line has its own method called hunt. What is the meaning of the line inheriting from animal? What this means is that the line is going to have all the attributes of animal, i.e. it's going to have, it's going to have, the line is going to inherit age, and it's going to inherit the sound method from animal. It's not going to inherit automatically the constructor. So that's one thing we need to keep in mind, that the constructor is not inherited, but all of these other attributes are going to be inherited. So the line has its own constructor in which we are constructing. It has its own constructor, which we are going to define. And it has got here the age of the animal. It's going to get automatically inherited. And it's also going to have the sound method of the animal, which it's going to automatically inherit. So what we see as a line actually has, because of inheritance, at its heart, it's got an animal with all of the animal attributes, plus, i.e. all of the animal genes. And on top of that, it's also got an additional feature, which not every animal has, which is the hunt feature, and it's the hunt behavior. And it's also got a characteristic called carnivore. So in a sense, this child class is bigger than the animal class. The line class is bigger than the animal class because it contains more information. How do we go ahead and implement these methods? The implemented methods are the constructor. And as you can see, the constructor for the line, these two colons in animal A, says call the animal constructor and pass to the animal constructor the age. So this goes into the animal, because remember, the line at heart is an animal. So the animal constructor is called to create an inner animal, and then the other attribute is set here. And then the hunt method for the line. The line does not have its own sound method. It is now inherited the sound method of the animal. And we'll see what happens if we write a sound method for line. So now how to create a line? We just use the regular object-oriented syntax, and we've got a line called L, and we pass true for is it a carnivore, and we pass the age as 5. And now we say l.sound and l.hunt, and let's run this. So you see this l.sound calls the sound method. The question is which sound method is going to get called. If we go and look into line, the line does not have its own sound method. It's inherited the sound method of the animal, and that is what is going to get called. So when you say l.sound, it's going to be the sound method that the line has inherited from the animal, and that method just says this is an animal sound, and that's what's going to get displayed. But when you do l.hunt, then as you can see, this is an additional method that the line has, which is not there in animal, and it is the hunt method that gets called. Now, let's try to see what happens if we give a sound method to the line. So an animal has a sound method, line inherits from animal, and it also defined its own personal characteristic sound method. So it potentially inherits from animal, but it also has its own sound method. So what's going to happen here? So as you can see, if the child method has a method which is of the same name as its parent, i.e., it has the ability to inherit the sound method of the parent, but it also has its own method of the same name, then it is the child method that's going to get called, which means the child can do the same exact functionality or behavior, but do it in its own way. So even if it inherits that same gene, but it chooses to reprogram that gene, then it can do so, and that's exactly what's happened. The child can also have its own new behaviors, which the parent does not have, for example, the hunt method, and then if you want the child to exhibit that behavior, then that's what gets called. This is a very important feature called overriding, and this is what makes inheritance very powerful and builds into the functionality of how we can use inheritance to create very large